Hello, everyone. Welcome to our second in a series of the Don't Panic webinars regarding the new California state requirements for skilled nursing facility power systems. Today, we are going to be talking about largely a technical deep dive into the aspects of what's required by the new law and code. And then we'll also get into some of the national codes and how these intersect with one another. We're fortunate to have what I would call two critical experts here. First of all, we have Jamie Schnick from the Healthcare Access and Information Agency of California. He's the senior lead electrical engineer and has been involved in significant energy projects, and we've worked together quite a bit. Jamie will be talking about the HCAI and state perspectives on what's required based on this new law. And then second of all, we have Walt Vernon, who has too many degrees for me to possibly list, and is also the CEO of Mazzetti, which is the premier engineering organization for, among other things, healthcare systems, and particularly healthcare power systems. Walt, among many things, happens to be an expert at the national codes and is very much plugged in with thought leaders and political leaders in this respect, and he'll be reflecting on those things. We have several additional experts from HCAI, which I'll ask Jamie to introduce at the beginning of his talk, but we'll start with Jamie's discussion about the state requirements.
Thank you, David. On the line, we also have Larry Edwright. He's our Building Standard Unit Mechanical Lead Engineer, technical lead for HCAI. Timothy Pyland, who oversees our Special Seismic Certification programs, and Nancy Timmons, our Chief Fire Life Safety Officer. So, as he said, I'm going to talk about the new law. I'm going to talk about PIN 74, which give some process on how to get started with this compliance requirement, and then also talk about some design aspects. PIN 74 was developed for skilled nursing facilities alternate power source. The reason PIN 74 was created was because a bill that was on the docket was signed into law at the end of last year, and it added section 1418.22 to Health and Safety Code, which requires skilled nursing facilities to have an alternate source of power to protect residents' health and safety for no fewer than 96 hours during any type of power outages. There were some definitions that were included in the bill. And essentially, the requirement is backup power for cooling and for life-saving equipment and for oxygen generating devices. Again, the PIN was basically developed to provide a policy for the implementation of this alternate source requirement as required by the new bill. As brief background, SNFs are regulated, and HCAI oversees the construction design of those facilities. Previously, the code only required 6 hours on-site fuel storage for emergency power systems. And the code mandated backup did not include cooling equipment. So essentially, this new requirement adds cooling, which is typically not on emergency power, and it adds the requirement for 96 hours, which previously was 6 hours. Just as far as the process, the PIN identifies assessment and then compliance. And so the first step for compliance is to do an on-site source of power assessment. The PIN states that SNFs shall submit an evaluation of on-site sources of power and evaluate them for compliance with this law. The process for doing that, you can find that on HCAI's website. If you start off and go to hcica.gov, and then you pick the Building Safety and Finance tab, you'll see there's an e-services portal. That e-services portal on the bottom of the sheet lists a number of user guides. And the last user guide on that list, number 22, is for SNF power assessment. Once you navigate to this assessment, you'll find our user guide, which shows you how to use this. There's a little bit of homework in the user guide. It's going to ask for you to assemble floor plans showing your existing equipment for cooling and heating, document your on-site emergency power provisions, and essentially, as you go through the assessment, we'll be looking at each of these systems: heating, cooling, ventilation, life-saving equipment, and oxygen generating equipment. Once you have the documents assembled, you should go to the ESP website, and you would be able to now create an application. This application will start the process of the assessment as it and be the process for officially submitting it to our agency. Click the enforcement button, and then down here you'll see there's two options. So obviously, select the SNF backup power assessment. The application involves a series of questions about the systems, as we talked about before. Each question will have a link. So essentially, if you start off heating equipment, are there heating equipments currently in place at the facility? If you select yes, there'll be follow-up questions about does it bring the facility to the minimum temperature above 71 degrees? Does it have backup power capabilities? As you go through this checklist, it'll develop on the bottom a running total of the questions that you've asked and that you've answered. You're able to come in and out of this program, and it'll, once you start the submittal process, it'll save the work that you've done previously. And you'll see, for instance, if one of the items is has related questions below, like are there ventilators on site? If the answer is no, then those other questions associated with that will be disabled. At the bottom, as you're answering your questions, this program will build a requirements based on the answers that you've given. You would need to put together your existing heating plans. Depending on how you answer, there'd be more detailed of what's required. After the submission is complete, the requirements displayed on the checklist are available in a report. So essentially, once you fill out the report, you submit it. As you submit it, you can put a cover letter. Basically, this will give results as far as whether you meet the requirements of the law and where you don't. And when that comes in, that would come to HCAI to review. So we put together this little flow chart to explain how the process works. The initial is the assessment. So starting up here at the top with the facility, you pull together your documents. You go ahead and fill out the assessment and you submit it to HCAI. HCAI takes that in and determines whether it's properly filled out or if there's some information missing. If there's information missing or lacking, then it would come back to a letter would be sent back to the entity that submitted it with the corrections required. They would resubmit and it gets back into the process. So if the submittal is accurate and appropriate, then it would come through here for HCAI to evaluate if it's compliant or not. I'll go the easy way first. If it is compliant, then we would take that, review it, either agree or disagree. If we agree, we would put that over to CDPH for their concurrence. If CDPH agrees that it's compliant, down here they review. If they agree, concur, then we would send a compliant letter would be sent to the owner, and you would have that on file, and the assessment would be complete. You would be legal at that point. If either CDPH or HCAI finds that the documentation shows that it's not compliant, then that would be sent back to the facility. The letter would be sent to them. They could take a look at what their options are. They would determine, is there a construction project required to bring the facility up to compliance or not? And that whole process would start all over. That whole process would follow through. If they think no construction, then they'd resubmit the assessment with some modifications. If they feel like construction is required, they would go ahead and, under a separate project number, submit a project for construction. Once the construction is completed, they would submit the new assessment application. So where the deficiencies were identified the first time, the construction ideally would solve those deficiencies. And then the form would be resubmitted, again, back to the review process for final approval. This is included in the PIN that we put together, but we just thought we would talk it through at this time. Now I'm going to transition over and talk about the technical side. Really, I do want to, the technical side, especially for us engineers, the funnest part to talk to and sort through. But I do want to emphasize that the analysis, the facility evaluation should take place first. We should come to an agreement between the facility and our organization on what the deficiencies are and what a possible solution would be. So now, if you're looking at a construction project to remediate or bring the facility up into code compliance, I've identified 3 possible approaches. Obviously, there's other approaches that as they're evaluated or submitted, we'll evaluate those. But we're basically looking at 3 approaches. One I call the 517 approach, which is really solving it through emergency power. The other is a 701, which is adding resources for a legally required standby. And the third is Article 705. These are all CEC articles, and that is the interconnected electrical power source. In addition to the electrical components, we know in order to comply with the mandate for to be able to withstand an earthquake and continue to be operational, there's special seismic certification required. And in addition to the codes that we've talked at, there's a 96-hour on-site fuel. One thing we did add in the PIN is the acceptable durations. For life-saving and oxygen generating, we've identified 10 seconds. And for mechanical equipment, we've identified time appropriate to maintain the temperature zones that was indicated. So again, I'll step through these, but here's just like a brief summary of the 3 options. On the 517 solution, I think it's relevant to point out that 517 has definitions that identify alternate power source, 1 or more generators or battery systems were permitted, intended to provide power during an interruption of the normal electrical service. And essential electrical system, a system comprised of alternate sources of power and all connected distribution systems and ancillary equipment. The reason I include these is just to make the distinction that there's the power source and there's the distribution system that are required by the 517 for the essential branch. Here's a diagram that kind of shows this approach. And obviously, if you're going to use, typically, after the survey is complete, we'll find out if there's life-saving and oxygen generating equipment. If there is, and it's already on the equipment branch, then those would be backed up by the existing generator. If it isn't, there would need to be modifications. But the main modification that we see for these facilities is going to be for the cooling system. These are typically larger mechanical loads, and typically they're connected to the, I'm showing the main distribution bus. This is the normal normal distribution board that's fed by the utility. And typically, in order to bring it into compliance, you need to transfer that to be backed up the existing generator. A couple things that are required. There needs to be capacity on the existing generator to accept the new loads. That would be done by load studies. And if and there would be recircuiting for HVAC to get from the old board to the, or from the normal side to the emergency side. And the requirement for 96 hours of fuel would need to be met for this site. Typically, we said those generators would have 6 hours. And if, ideally, if you have this capacity on your generator, we definitely think this is probably the least impactful way to come into compliance with the code. Article 701. So the 701 legally required standby systems. The definition in the code is those systems required and so classed as legally required standby by municipal, state, federal, or other codes, or by any governmental agency having jurisdiction. They're intended to automatically supply power to selected loads other than those classed as emergency system in the event of failure of the normal source. So the code allows storage batteries, PVs, generator set, UPS, and fuel cell for sources for legally required standby systems. Diagrammatically, what this looks like, this existing generator would remain in place. And as I said initially, this emergency system that includes the generator, the distribution board, the transfer switch, all remain in place. And independent of that, a new generator or set of batteries or other that we listed before, storage batteries, PVs, generator set, UPS, fuel cell, could be introduced to the system and connected via a transfer switch. And then a new panel introduced into the distribution system. And again, here we go ahead and transfer the existing air conditioning loads to the new panel. In this case, this whole new system, the panel, the transfer switch, the generator would all need to be seismically compliant. The provision for the generator of 96 hours of fuel would be required. And the existing generator, which backs up the essential and the life safety and the equipment branch, would need to have provisions made to have 96 hours of fuel. Obviously, with the new generator introduced, the intent is to keep the building occupied and have it within temperature range as specified. And we would need to keep the building's emergency system up and operational for the entire 96 hours as well. Article 705. Now, this is the microgrid solution. And this is 705 is called interconnected electric power production sources. The microgrid system, a premises wiring that has generation, energy storage, and loads, or any combination that has the ability to disconnect and parallel with the primary source. Appropriate equipment includes PVs, battery units, fuel cells, microturbines, and the microgrid would have a control device, a microgrid interconnect device that we typically call a microgrid controller. Now, I want to revisit and what I think is an important point is that when we talk about 517, this is the emergency system, and this is the code drives requirements for the emergency system that need to be met. In this scenario, this is a standby system, and the code has requirements. You got to follow NFPA 110 on the generator, but it's not the emergency system. It's a separate branch from emergency. So all the requirements from 517 necessarily don't apply to this. And when we go to the 705 solution, again, the emergency system meets the code requirements. It meets the CMS refund requirements, and the microgrid does not need to. In this scenario, and this is really diagrammatic, it's inconceivable that a SNF would have a microturbine, fuel cell, batteries, and PVs. But I'm just for demonstration purposes listing these and showing how these would connect to the microgrid bus. The microgrid would have its own controller, and then that microgrid could be configured to the main distribution board. 705 has specific requirements about the sizing of this existing bus and the load that can be added to it. Obviously, we don't want to exceed the rating of this bus, but typically what we've seen is that could be met with little changes. The code requirement is that the rating of this bus needs to be 125%. 120% of the rating of this bus needs to exceed the summation of this main breaker of this board and the resources available. And typically what we see is that these breakers can be downsized to meet this code requirement. So in this case, we have the microgrid. It's not part of the emergency system. It has still has the requirements of special seismic certification because it's a new law. It has the requirements of 96 hours of fuel requirement. And we've talked previously, and we can go into that, but essentially the code, the law states 96 hours, of which 6 hours need to be resident on site. There is an option to have contract arrangements for fuel delivery, which the reliability and feasibility of that delivery system would need to be submitted and reviewed by CDPH for approval. But as I said, this system, all these components would need to be seismically certified to meet the requirements of the law, and they would need to have provisions for 96 hours of fuel. So as we look at this, I wanted to point out a couple comparisons. The 517 emergency system has requirement, seismic compliance requirement. It has, by code, current code, is required to have a generator. It's required to have 6 hours of fuel on site. It's required to have 2 independent sources, required to have ATSs, and additionally, CMS has requirements in place today that needs to be a generator. The difference between this AB25 solution is, yes, it needs to have requirement seismic compliance. AB 2511 does not require an emergency generator. Fuel storage is more than 6 hours, it's 96 hours. 2 independent sources are still required. ATSs are not required. So the reason I point this out, and once I show the next diagram, I'm going to ask Walt to jump in and kind of talk about current condition of codes and the evolutions of codes we see it, is that the solution that we saw previously in number 3, where this is completely independent and not part of the emergency system, it still has the requirements of the emergency system to be seismically certified. It still has the requirements of the emergency system to have special seismic certification. And so eventually we think as a future option that this solution could transition to also provide emergency power, which would allow the generators to not be required. In this case, all the requirements of 517 would be met. The sources seismically certified, the fuel over 6 hours, which is the only requirement for emergency power. And the system is completely independent. The code is very detailed on never the two shall meet except for in a transfer switch. That way the system is reliable in redundant pathways, and it would meet all of the requirements. One last thing that I neglected to point out is in the two previous solutions, and this is where we're at today. I wanted to show that last slide of where it could evolve to. But in the two previous solutions, you always had to go back to this generator and make upgrades to get to meet the 96-hour on-site fuel storage requirement. In this solution, you don't. Why is that? Because you have 96 hours already that's backing up the entire system. So you meet the requirements of the new law as far as your HVAC, life-saving oxygen generating, be backed up for 96, and you meet the requirements of the code of your life safety branch and your equipment branch being backed up for 6 hours. So Walt, I'm going to flip down to this, where we talk about the code comparison, how it relates to the law, and maybe you could share some information about where the codes are today and how they're evolving.
So, yeah, I'm going to do it. Well, Jamie, you should explain this table, and then I'll sort of move on from there, if that's all right.
Okay.
Because I think this table is really helpful. Yeah.
Right. I'll go back through this. So what I really wanted to point out is that the 517 requirements actually exceed the requirements that we see in the new AB 2511, but not by a lot. So 517 requires seismic compliance for your emergency power source, and AB 2511 also requires that. 517 requires a generator today in current code as it's written. The AB 2511 does not require a generator. 517 requires 6 hours of fuel. And in this case, AB 2511 has a stricter requirement of provision for 96 hours. The two independent sources are required. The ATS are required on the emergency side. So there's dual paths to all of your code mandated emergency loads. And then there's the CMS piece, which federal reimbursement requires that you meet CMS requirements, of which on the emergency side, it is required, and on the alternate power side, it isn't. And the reason I did that, and I'll just take one last look, is that what we're proposing, or what we're pointing out, is that the microgrid solution that meets the new bill's requirements is very nearly meets all the requirements of 517. So.
If I may, this is Dave Bliss. Before we have Walt jump in, I wanted to underscore a couple of things that came up in the chat and question box. And Jamie, I think you covered this, but just to reemphasize, first of all, the safe temperature range as HCAI is currently defining it is what?
I'll ask Larry Enright, our mechanical lead at HCAI, to answer that. Larry, could you take that one, please?
Yes. So in our pen and our guide, we refer back to the federal requirements where they call out the 71 to 81 degrees range for the safe temperature.
Thanks, Larry. Appreciate that. And then the other sort of point to underscore is the 96 hours of on-site fuel, which could either be 6 hours of on-site and 90 hours of delivered, or 96 hours on-site. Does that refer to fuel requirements for each resource that's on the site, or is that in aggregate all resources? That's
an aggregate. The intent is that the facility can operate for the 96 hours.
So in sort of more concrete terms, if you had, say, batteries and a fuel cell and a generator, it would be the total sum of all those assets put together would have to be able to supply 96 hours of continuous power up to the level required for the health and safety systems.
Yes, and this is a great question, because this is a new concept, a new way of looking at this runtime. We've always looked at on the emergency side, NFPA 110 says you need to have fuel to operate the generator fully loaded in this case, for the 6 hours. But the law only requires that you back up the actual load for 96 hours. And so what I think is there going to be some new scrutiny, new calculations that look at what does it take, how many kilowatt hours do you need to get your 96 hours of operation. And you could have contribution from fuel cells. Again, this would be fuel cells with fuel stored on site, and you could get, a number of kilowatt hours. You could have batteries that could give you a number of kilowatt hours. You could have PVs over the course of 96 hours, 4 days. You could come up with a calculation of how much energy you can harvest from the sun. You could have, generators. So yes, it would be a summation of all the resources and how much runtime, and that would be the calculation that we would be looking at to see that you meet the 96 hours. Very good question.
Perfect. So to keep moving along, Walt Vernon again is going to comment on the intersection of national codes and trends in national codes and how those intersect with the new California regulations. Walt, go ahead.
Yeah, and Jamie, I think you can stop sharing. I'm just going to talk
Will do.
Diagrams. And I think in some ways it's a really good segue, that conversation about the kilowatt hours capacity. It's something Jamie and I spent a lot of time talking about, because as we start to use these various technologies, all of which have different operating characteristics, thinking about the way they're going to work together in response to the load demands of the facility is going to be really important. And it's not just simply multiplying the capacity of the generator, or the capacity of the generator by 96 hours of fuel anymore, right? We actually have to do engineering now, I think, to try to figure out the best combination to optimize both the economic impact as well as the reliability that's needed by the patients and staff. So it's always a pleasure to present with Jamie, because he does such a thorough job of explaining important concepts. And frankly, in this particular case, I think he's done an amazing job of thinking through the various ways that different facilities can meet these requirements using really creative solutions. And I kind of want to build on the notion that Jamie sort of set forth about the microgrid potential and how that could be understood, as David said, in the context of where national codes are trending. So, in addition to this particular requirement and the particular edition of the California Energy or Electrical Code that we're all dealing with today, first I want to point out that there are also air quality and increasingly carbon regulations that are impacting facilities and designs. And we haven't really talked about those, but the trajectory of those regulations is clearly increasing stringency. So the easy diesel generator strategy, I think is probably not the solution of the future. Also, sort of out there separate from electrical requirements are what we're seeing increasingly around the country in terms of building performance standards and regulations on buildings to reduce the amount of energy that they are consuming, except for renewable sources. So I think there's sort of a parallel set of pressures on us to be thinking about reducing our energy consumed from fossil fuel sources that are going to be influential in the long run. And I think that's important, because as we make these decisions about how to react to this particular set of regulations, doing it in a way, I think, that is forward-looking and not just responding to today's codes is going to really help us to make sure that we don't create a lot of stranded assets in the form of diesel generators that may not be the best solution for us long-term. So I wanted to talk for a second about the NFPA codes. There are 3 major NFPA codes that deal with this issue: 99, 70, and 110. We're probably all familiar with all of those in various ways. 99, the healthcare code, is not enforced by California, but it is really the root document for both 70 and 110. Today, the current edition of 99 that's published is 2021. The current edition of NFPA 70 is 2023, and 110 is 2022. And these things all get, they're all always out of sync, because every time one is updated, then the next one has to be updated and the next one. And so 99 tends to lead. 99 is to define performance characteristics that systems need to have to serve the hospital. Then the NEC comes along and says, okay, to deliver that performance, here's some specific regulations to make it happen. And then 110 comes along and says, okay, to operate and maintain what's in the NEC, here's what's required. So it's always sort of out of sync in that way. Today, 99, the current edition, permits the use of microgrids as emergency power sources. Today, the NEC doesn't permit that, and nor does 110. But the new edition of the NEC, the 2023 edition, is now permitting the use of microgrids as emergency power sources. And so at some point, California will adopt those regulations, and those systems, those renewable energy microgrids, will be available as emergency power, the 517 systems that Jamie talked about, which is why the design that he contemplated in terms of a microgrid that could ultimately do both this set of requirements as well as the 517 requirements could be a really important thing to keep in mind. 110 today is only dealing with fuel cells. So it has expanded its capacity. It only used to deal with fossil fuel generated generators in the sense that we're accustomed to. Now they've expanded to include fuel cells. And what's more important in some ways in terms of trajectory is that 99, the 2024 edition of 99, which has not been published yet, but I sit on the committee that wrote it, is actually now eliminating the distinction between a normal source and an emergency source. And it is looking at the promise of the microgrid as a collection of many resources, including utilities, including on-site generation, with multiple pathways to supply medical facilities of all types, including nursing homes. And where the codes are moving, it appears, is towards something like what Jamie was describing when he was talking about on-site storage and how we think about on-site storage, because we're really moving more to a performance-oriented set of requirements and not so much a prescriptive-oriented set of requirements. And again, in some ways, all of this is irrelevant because it's not in place today. Today, all you've got to do is do what Jamie said, and you'll meet the intent of the code. But because of the trajectory of all of the different codes, I think it's really important that as we think about the right solution for any particular facility, picking one that's thinking about where the codes are headed will help future-proof us and help us avoid the problem of stranded assets. And we're not talking about money today, but certainly we have the mechanisms to do it. And so really, really important, I think. Maybe, let's see, what else do I want to say about that? Maybe two other things. One of the issues we've had, and Jamie identified, is the seismic certification, right? Today, I don't think there's a seismically certified solar panel. There's not a seismically certified battery. There's not a seismically certified microgrid controller. And that's partly because when you go to the solar companies and say, I need you to do this, they say, but why should I? Because it's not permitted by the code, right? So we've had a chicken or the egg problem historically in our industry. And now I think with these evolving codes, it's really incumbent upon us as the designers, as the regulators, as the owners of these systems to start pressuring the vendors to say, I need this, I need this, I need this, make it happen. And you know, if you're a solar panel manufacturer, you can have first mover advantage by getting that seismic certification, and you'll be the one that's in demand. And so huge commercial opportunity here, but we've got to issue the demand signal. So that's a really, really important thing as we do these. And the last thing that I wanted to mention is CMS certification or reimbursement. So many people are familiar with CMS Conditions of Participation, which state the requirements that a facility must meet, the minimum standards, in order to receive reimbursement. And as I've talked through the years about the various possibilities around fuel cells and microgrids, and how these codes are painfully slowly evolving, but at least they are moving. One of the things I always hear from people is, but we can't do it because CMS won't reimburse us. CMS today is enforcing the 2012 edition of NFPA 99 and 101. It actually doesn't invoke any edition of the National Electrical Code, but both 110 and 99 do incorporate the 2011, I think it is, edition of the National Electrical Code. So by reference, that is the version that's included in the CMS Conditions of Participation. You may be familiar that Senator Markey of Massachusetts recently issued a public letter asking CMS to re-examine this, because the federal government, through the Inflation Reduction Act, has just made a ton of money available to people to invest in these on-site renewable assets. People are scared because they're afraid if they access that money, they won't meet the conditions of participation and they will jeopardize their reimbursement status. And so Senator Markey has said, hey, look, Congress intended for this money to be used, not for the federal government to get in the way of its being used. And so he and others are starting to put pressure on CMS to issue a waiver. The process by which CMS will actually update the codes that it requires is a very laborious, time-consuming, highly regulatory process. But they have the ability to issue a waiver. And so what is being asked of CMS is to issue a waiver to allow the 2023 National Electrical Code, Section 517, which permits the use of renewable energy microgrids in lieu of diesel generators. Now, that does not solve, as Jamie mentioned, the seismic certification problem. It does not solve issues about on-site storage, except insofar as batteries could be that storage. But it removes one of the barriers and creates a path to acceleration of this new future that I think we're all looking forward to creating together. So I guess the message again from me, and I serve on both NFPA 99 and NFPA 70, so I'm sort of actively writing these codes. The national codes are moving towards microgrids, including renewable assets. The reimbursement is moving in that direction. And so as we in California think about the right answers to these challenges of the emergency systems we've got to provide, thinking about how to future-proof and avoid stranded assets will highly benefit you in the future. And with that, I think, David, I want to hand it to you for Q&A.
Perfect. So to clarify something, Walt, with the CMS, and just to use an example of Jamie's, if a facility had a diesel generator that already served the previously required loads, in other words, maybe not covering HVAC, and somehow were able to come up with the 96 hours of fuel in one form, but they added a microgrid to now deal with the HVAC requirements, and again, assuming seismic was done, that sounds like it would not run afoul of CMS requirements, because the systems that CMS requires support for remain under the generator. But if I made the distinction that if you wanted to decommission the generator and substitute in a microgrid right now at this time, absent a waiver, then you could run afoul of CMS. Is that a reasonable distinction?
Yes, and I think that's the genius behind what Jamie proposed, actually, because it threads that needle. But in some ways, I wouldn't worry too much about that because I think the waiver will be coming within a very few months. And so, but again, we still have the problems with the fuel and the seismic certification we've got to get solved. But yes, that's exactly right, David.
Jamie, any comments in that regard?
Yeah, that solution that I showed and then transitioning to that microgrid being the emergency source, it has a tremendous advantage as far as the testing and functioning of your microgrid will take time. And these aren't new buildings. These are buildings that are currently occupied and have, residents. And so while you're doing that commissioning, while you're doing that testing, to have the generator, the old generator stay in place is a tremendous benefit. And so I think that part of it is creates just another opportunity to implement this solution for our buildings.
So let me transition to a couple of questions that have come up in the Q&A. First of all, and I'm just going to read these directly. Most facilities have small generators that only power red plugs. They would need to get new generators or a microgrid in place. All this by January 2024, question mark. What is the usual timeline for HCAI to approve new generator or microgrid plans? So Jamie, I'll toss that one to you, obviously.
Thank you. Well, as I said, the first step is the assessment. And we have a task force that's prepared to turn these drawings around quickly. And to be honest, the completeness and appropriateness, or code compliance of those drawings has a direct bearing on how quickly they can be turned around. So we are aware of the time crunch, and we're arranged to try to facilitate that. Now, as I say that, and there's 1,200 some SNFs in the state, it's a monumental task. But we have, I said, arranged a group to be prepared to take those in and turn them out as quick as possible.
Now, something we've discussed in different forums is the possibility that if a facility puts a plan in place before this January 2024 guideline and has a reasonable execution plan, that may turn out to be an acceptable approach. That's not encoded in the law. The law is pretty clear about it having to be January 1st, 2024. But you have any thoughts about, there's different ways facilities might do this. They might choose to say, well, I'm going to wait for modifications to the law. I'm going to put a process in place, but not complete it. Or I'm going to, really sprint and get this done before January 1st. You have any thoughts about that middling approach, where you might put a plan in place and have HCAI approve your plan?
Well, this is the case where I need to stay in my swim lane. HCAI, is tasked with putting together the policy to meet the requirement of the law and to review the plans for compliance. There's another agency that's tasked with the licensing and the fines that would come into play. And so respectfully, I choose to not answer that because it's really not our role.
Understood. I'm asking not to sort of make life difficult, but that's an inevitable question. Okay, let me switch to a very specific technical question. So there's a facility that says that they have two conventional generators, I presume, both of which have 96 hours of fuel support on site. And I was asked, or we were asked, would that be compliant? And I initially responded, as long as all of the specified loads are supported during emergency circumstances, including the new HVAC provision, presumably that would meet requirements. And I may have gone out on a limb there. But the follow-up question is, we have dual, and I'm reading this now, we have dual outlet, which is to say when power goes down, we switch to outlet usage. These are clearly marked emergency power source throughout the facility. We're able to function, I think they meant to say we are able to function all emergency needs. Does this sound correct?
Yeah, I think there's two requirements. There's the 517 requirements, regardless of that still remain in play, which is that the code mandated life safety and equipment loads need to be backed up by an emergency generator. And then there's the new requirements for the cooling and life-saving and oxygen generating devices. So it sounds like that facility is in really good shape just to have compliance. But what they need to do is to fill out the assessment, because if we don't have the assessment that shows the compliance, and then it'll be shared with us, we'll scrutinize it and obviously accept it if it shows compliance, and then it goes to CDPH. That process needs to take place for the facility to be to show that they comply with the law.
And then again, to emphasize, Jamie, you put this in your talk, they can go to the HCAI website and fill out that assessment digitally right on through the website and get an answer through that mechanism. Is that correct?
Yes.
Okay, perfect. Well, while we're waiting for other questions to come into the chat, let me phrase a couple of my own. This is for Larry. What if a facility is in an area where average temps never go above 81 degrees and the facility doesn't currently have cooling? Does cooling need to be added for rare heat wave days where temps go above 80 for a couple of hours 2 to 3 times a year?
We've been looking at that. So if a facility does not currently have cooling, the standard isn't to provide cooling equipment, it's to provide backup power for equipment. So we wouldn't necessarily require that. That would need to be introduced in the assessment with a little narrative to explain why, a little background information for that.
So Larry, the implication of the question is, would a facility be compelled to install an HVAC or air conditioning specific system specifically? And the law doesn't compel that, at least as it's currently written. Is that correct?
That's how we're looking at it. There's plenty of areas where they may not have cooling right now, and they would continue to be that way. At that point in the assessment, we would be looking for the emergency plan to show a portable type of equipment to be able to do that. So there might be some outlets or something that might need to be added to power some portable equipment, something like that.
And as a follow-on to that, are all areas within a skilled nursing facility subject to the temperature requirements, or is it only specific areas within the facility?
So in our PIN 74, we're looking at the laws for patient safety. So it's patients and stores. So pretty much the procedural processes of the area. If there's any admin areas or additional areas that aren't necessarily helpful to the patients, then those areas do not need to be included. As part of the assessment, we do ask for a little plan of the building and to show where the units are and which areas they serve, and to show which ones that they believe are the patient care areas, to individualize and isolate which systems need to be a part of this.
So one might surmise, for example, that a kitchen, a cooking area, which isn't necessarily for patient safety, may not be affected, but the eating area might be, as an example.
Yeah, exactly.
Okay, perfect. Well, for Tim then, if PVs are used as a component, meaning photovoltaic arrays are used as a component of the alternate source, would just the feed to the building be evaluated for code AB 2511 compliance, or would the panels, collectors, inverters, and all the other equipment related need to be seismically certified?
Sorry, rephrase the question, the first part of the question.
If a photovoltaic system, panels, et cetera, are used as an alternate source,
Correct.
would all of the PV related equipment, meaning panels, racking, et cetera, inverters, need to be seismically certified, or only the connections?
It would be the entire system.
Okay.
Ensure structural stability and functionality after any natural disaster.
Is there ever a scenario in which backup systems do not have to be seismically certified?
Right now, it's just emergency standby power systems. So if it doesn't fall into that category, we have no jurisdiction to require special assignment certification.
So meaning if a system is supplemental and not the, one of the two resources required, then HCAI wouldn't have a seismic concern?
Well, currently it's only the emergency standby power system. So if you have another alternate power source, as Jamie mentioned, that would fall under his category with regard to whether it requires special assignment certification. If it must meet AB 2511, then it would require special assignment certification. So.
Okie doke. All right, Nancy, fire life safety. Are there safety issues for storing 96 hours of fuel? And I'll add to that. Are there any opinions from HCAI with respect to above ground, below ground, or delivered fuel with respect to safety? And Nancy, you may need to unmute yourself. Well, maybe we've lost Nancy for the moment. Nancy, if you come on, let me know, and I'll come back to you.
Okay.
Oh, there we are. Go ahead, Nancy.
Oh, can you hear? Sorry, you heard that part, huh? Thank you, David. I'm on my headphones. They weren't transferring for some reason. So yes, thank you for asking that. There are requirements for the extra fuel if you've got the underground tank or more fuel added to what's already. Hear me?
Sorry, you broke up there a little bit.
Oh, that's okay. That's okay. Can you hear me now?
Yes.
Okay, it switched back to the other microphone. Sorry about that. So yes, there are requirements for the tanks, but in looking at our website, you'll see reminder list for the different types of tanks, whether it's underground or above ground. And then also the CUPA requirements. There's a requirement for the tanks to go through certain regulate. Let me close the door. I think the background noise might be bad.
Okay.
There's requirements for locals to look at with regarding the tanks and the hazardous materials and the different regulations that come into play based on the amount of fuel that's going to be added to the tanks or to the facility in addition to what they already have or new. So those requirements or that's not new to us. If you look at PIN 2, also found on our site, there's a little bit of information there. The problem with that right now is what CUPA is saying, or individuals that are speaking on behalf of CUPA, are if a project came into play today, they're still 18 months out. So if you're going to go the route of adding tanks or adding fuel, to cooperate, get in touch with the locals as soon as possible to get that ball rolling. We do that as well on our end when we have a project, even any project that involves the tanks. We have a form that we'll send out to the design professional, and that item will be listed on that form to have the locals approve that. And so we also try to start that ball rolling pretty early on as well.
Great, appreciate that, Nancy. Well, we're almost out of time, so I want to give the two speakers a minute or two to wrap things up. I want to thank Mazzetti for joining Faraday and hosting this webinar. We hope it's been useful to folks, and we will be holding follow-up webinars to dive a little bit deeper into things in the very near future. On February 9th at 11 a.m., we'll be doing a bit of a town hall roundtable. And then on March 9th, we'll be doing a finance of these systems discussion as well. So let me give Walt the first shot. Walt, any thoughts to wrap up?
Well, again, I would simply say the easy solution of throwing another diesel generator in might be seductive, but given the trajectory of the national codes, given the funding that's now available, and we'll talk about in a couple of weeks, I strongly recommend, and I think, and Jamie and I have talked about this, the loads that we're talking about are not huge. I think we could today put in place solar and battery systems that would pick up this additional load that's needed. at a reasonable cost and future-proof the buildings. And so I would strongly recommend considering those options.
Jamie, any closing thoughts? You want to unmute yourself.
Yeah, just want to say I appreciate everybody's looking into this. It's something that was it's a new law, so we've tried to react as quickly as we can to get the policy out, and we're here to help. So thank you.
Well, I want to also, if I neglect to say this, I want to thank the entire HCAI team, Larry, Tim, and Nancy, as well as Jamie, for coming to this and participating. They've been great partners in terms of digesting all this information, getting out the pins, and then communicating through these educational webinars. So we very much appreciate the time and effort you guys have put in and the collaboration on all of this. We've hit the top of the hour, so we'll go ahead and end the webinar for today. Again, keep a lookout for the upcoming webinars where we'll share additional information and take additional questions. And we're very grateful for your participation. Enjoy the day.